Welcome to the video lecture of Comparative Design. This video discusses Module 3, CLR and LALR parser. Again, in the syllabus, this video is focusing on canonical LR parsing table and construction of LALR parsing table. Already we have discussed about shift reduce and reduce conflict. In the previous slide or previous presentation, we have discussed about the SLR parsing table. Whenever we construct an SLR parsing table, if a shift reduce or reduce conflict occur, then that grammar will not be SLR grammar. In that case, we have to construct CLR parser. Consider this example. This is an example of a grammar which has got a shift reduce conflict. This was the grammar which is shown like S gives L is equal to R and S gives R, L gives star R, L gives ID, R gives L. This is a given set of production. While we construct an SLR parser, initially we will construct the canonical LR0 collection, that is the item construction. While we construct the set of LR0 items, while we look into the I2 closure, we can see that goto of I2 equal to, goto of I2 comma equal to, that will be S gives L is equal to dot R, that is I6. So in the parsing table corresponding to 2 under this equal to, we have to write S6, shift 6. But whereas in the case of R gives L dot, that is an item which is getting completed, which is actually a production. That production is 3rd, 4th, 5th production. So we have to consider that R5 is getting completed here. R gives L dot. And we have to write that R5 corresponding to 2 under the follow of R. Follow of R is equal to and dollar. So equal to, we have already written S6. So in the same place, another chance came so that we have to write this R5. So this is actually an example of shift reduce conflict. Consider another example, which is an example of reduce conflict. If here we are given set of production, S gives capital A comma, S gives capital A, small small b, S gives capital B, small small A gives epsilon, B gives epsilon. So we initially prepare the set of LR0 item, that is, we will start with the augmented grammar S dash gives dot S. So initially that will be added. So in addition to that, since dot, after the dot the non-terminal S comes, so here we have to add the S productions with the dot on its leftmost end. In this case, second production, and after the dot there is a capital A, so we have to add the productions of capital A, and that is A gives epsilon. One thing we have to notice here is that if the production is having only epsilon on its right hand side, we have to simply put a dot over the right hand side in the item construction. Similarly, when we check the S gives dot B, after the dot there is a non-terminal capital B, so we have to add the B production. Similarly for B also there is only epsilon on the right hand side. So while we produce an item for such cases, that is only RHS is having epsilon, just put a single dot over the right hand side, there the item ends. So in this case, while we consider A gives epsilon and B gives epsilon, the items are ending in I0 itself. So 0 under follow of A and follow of B, we have to write this R3 and R4, that is A gives epsilon and B gives epsilon are R3 and R4 productions respectively, so R3 and R4, but we have to write it under follow of A and follow of B. But when we observe follow of A, follow of B, we can see that both of them are containing the same terminals A and B. So it is sure that if we write R3 and R4 corresponding to 0 under A and B, it will give a clash. So we can say that it is an example of reduce conflict. So this grammar is also not an SLR grammar. In such a cases, if we are having conflict, we should opt for, or we should go. In the case of CLR parser, the canonical collection of items, it is actually collection of LR1 item, that is instead of LR0 in the case of SLR parser, here in the case of canonical LR parser we have to construct a set of LR1 item. One is here, that is one look ahead. One stands for look ahead symbol, so one look ahead symbol is to be added. So in the case of construction of LR1 item also we have to follow the closure and go to operations. Here the closure is defined as that every LR1 item in I is in closure of I, similar to what we have done in SLR1 parser. Also, if there is a look ahead symbol, that means surely it will be having a look ahead symbol that is represented as A is alpha dot B beta comma A. That means the closure will be having, in addition to the item, there will be a look ahead symbol. So that look ahead symbol is represented as small letter A. So if you can compare each item in the closure with this general rule of the production, A is alpha dot B beta comma A. If the productions if the items in the closure are of this form, we have to identify what is first of beta A. Before that, since after the dot there is a non-terminal capital B, we have to add the productions of B with a dot on the left hand side of its RHS. But while we add this B production, its look ahead symbol is to be identified. For that we have to identify the look ahead symbol using this rule, first of beta A. What is first of beta A? That will be a set of terminals. So that will be the B corresponding to B gives dot gamma. Then this is go to operation, which we can do similar to what we have done for SLR1 parser. That means if the item is of the form A gives alpha dot x beta comma A in capital I, that is after the dot there is a capital X. It may be a terminal or it can be a non-terminal. Whatever be the case, we have to shift the dot one position right. That means after applying go to, the item becomes A gives alpha x dot beta comma A. The same look ahead symbol will be copied to the initial item. The same thing, construction of LR1 collection is explained with using algorithm, that is it combines both closure and go to operation. So we have the closure operation here. Eventually one thing is you have to notice here is that while we add the first item as s dash is dot s, the look ahead symbol is by default dollar. Then repeat the following until no more set of LR1 item can be added to the closure. Then for each item in closure we have to find go to. Then again we are saying that go to can be represented as a DFA. Another thing we can notice is that whether if more than one production, more than one items are having the same part, that is here only the look aheads are different, but this part A is alpha dot beta, A is alpha dot beta, they are same for this production. Only the look aheads are different. In that case, we can put that production items together by putting the look ahead symbol as alternative options. Then this slide discusses an example of constructing a CLR parsing table. We are considering the production capital S keys, capital C, capital C, capital C is small c, capital C or D. This is an university question usually asked for construction of CLR parsing table. Then as the first step, similarly for the SLR1 parsing table, in the CLR parsing table also we have to construct the augmented grammar. How we can augment the grammar? We can augment the grammar by adding the production S dash gives S. Here S is a start symbol, so S dash gives S. So this is the new augmented grammar. Then this is the construction of, this slide shows the construction of LR1 item. Initially I0 is to be build, that is s dash gives dot s comma dollar, that by default we have to add it as the first item, and dollar is the first default look ahead symbol. Then since after the dot the capital S is there, it is a non-terminal, so we have to seek the productions of capital S. The productions are S gives CC, C gives small c, capital C or T. Here the S productions are only S gives capital C, capital C. So we have to add that with a dot on the left hand side. So we have added that with a dot on the left hand side. Then how we can add this look ahead dollar, that I can explain with the help of this image. That is, for how we can add this is S dash gives dot s comma dollar. So we have to write it in the form of A gives alpha dot B beta comma A. One thing you have to remember is that while we write after the dot, there should be a non-terminal. So B should be written such that B should point to the non-terminal after the dot. So here A corresponds to S dash, alpha corresponds to epsilon. There is nothing before the dot. Capital B corresponds to capital S, beta corresponds to epsilon, and a small letter a correspond to dollar, that is the look ahead symbol. So what is first of beta A, that we have to identify. Beta is epsilon, so only remaining one is A. So first of A, that is first of dollar, is equal to dollar. So that dollar is put here. So this dollar comes like this. From this S dash gives dot s comma dollar, this we have to apply A gives alpha dot B beta comma A, identify first of beta A, then that result will be added as look ahead symbol of this production S gives dot CC. Similarly, while we consider the next item S gives dot CC comma dollar, after the dot there is capital C. Capital C, the production of capital C is Z gives small c, capital C, also C gives D. Two alternatives are for the capital C. So we have to add both alternatives with a production with its right hand side having a dot at its leftmost end. And how we can add that look ahead symbol for this? This look ahead symbol also comes from the item S gives dot CC comma dollar. So we can examine that. Again, you consider S gives dot CC. That is, S gives dot CC means similarly in the case it is not given in this image, that you can observe here itself. A gives alpha dot B beta comma A. Alpha dot B beta comma A. Yes, it is given here. Sorry. A gives alpha dot B beta comma A. That is, B is capital C and capital C is beta, and A corresponds to dollar. So capital A corresponds to S, capital B corresponds to C, capital beta corresponds to C, A corresponds to dollar. So first of beta A means first of capital C dollar. So first of capital C is actually small letter c and small letter d. So that will be the first of beta A. So that will be added to this item as well as this item, since it came from S gives dot CC comma dollar. Then after the dot there is no non-terminal, so the closure ends here. No further production can be added to this closure. So the closure I0 is over. Then what is the next step? We have to identify the goto function. The goto of I0 on capital S. That is, we have to shift the dot one position right. S dash gives S dot comma. This look ahead symbol is to be copied as such. Then to the closure I1 we cannot add any more production because after the dot nothing is there. Then what is the next goto? Goto of I0 on capital C. So what will be goto of I0 on capital C? S gives capital C dot, shift the dot one position right, dot C comma dollar. This dollar exactly copied from that. Then in the case of I2, after the dot there is capital C. So we have to add the productions of capital C, both the production with the dot at its leftmost end, dot CC dot T. But how this dollar came, that we have to observe. That is here given at us. S gives C dot C, comma dollar. So again you write it in the form of A gives alpha dot B beta comma A. Identify first of beta A. So here beta is corresponds to epsilon and A correspond to dollar. So that is first of dollar is equal to dollar. So that's why both items are having dollar. Similarly, I check for any other closure we can add. Since after the dot there is terminal and here also after the dot there is terminal, we cannot add no more items to this closure. So the closure operation for I2 is closed here. Now we have to seek for goto. Goto of I2 on capital C, that is goto of before we come to that, we have to finish the goto of I0. So goto of I0 on small c, that is I0 on small c, capital C gives C dot capital C comma C bar D. That is exactly copied. That look ahead symbol is copied, C bar D. Then here after the dot there is non-terminal, so add the productions of the capital C with the dot at its leftmost end. Then how this production has got this item has got the C bar D. Again, write it in the form of A gives alpha dot B beta comma A. So B beta is absent, A is C bar D. So first of A, that is first of C bar D is C bar D. So that is why both of these items are having C bar D. So there is next you look for any chance of adding further items to this closure. Here after the dot there is terminal capital C small letter C, and after the dot there is terminal small letter D. So there is no chance because there is no non-terminal after the dot, so we cannot add any more items to this closure. So next option is I0 on D. I0 on D means goto of I0 on D, C gives D dot and we have to copy the look ahead symbol C bar D exactly as such, C bar D. So we have completed the closure operation of I0 and goto operation of I0. Similarly, you look for I1. I1, we have to identify if there is any goto. No goto because after the dot there is no symbol. In the case of I2, goto of I2 on capital C. Goto of I2 on capital C is S gives ZZ dot dollar. Then goto of I2 on small c. C gives C dot C comma dollar. This dot is exactly copied. Whereas we have to add more productions of C into this closure because after the dot there is non-terminal capital C. So capital C, the productions are C gives dot CC, Z gives dot D. Then how this dollar came? This is again you apply A gives alpha dot B beta comma A. First of beta A. First of beta A is again beta is epsilon, A is dollar. So first of dollar is dollar. So that dollar will be copied to this both items as the look ahead symbol. Then again you look for that goto of I2 on small c, that is C gives small c dot capital C comma dollar. So that is here. Then C gives dot D, that is I goto of I0 on D, that is C gives D dot comma dollar. Then I3, in the case of I3, goto of I3 on capital C. Goto of I3 on capital C will be capital C gives C, then capital C dot. Capital C dot means the look ahead symbol is C bar D. So that will be copied, that is I8. In the case of second item, that is after the dot there is small c. So goto on I3 on small c. That will be, we are expecting it's goto as C gives, capital C gives small c dot capital C and its look ahead symbol as C bar D. If we look once again into the I3 closure, it is the same that we are expecting. So we have indicated that it is a self loop. Then C is dot D. I3 on D, that is C gives D dot, that is the look ahead is C bar D. Even though there is a C gives D dot here, the look ahead is different, so we cannot point to that I7. So since the look ahead is different, we have to we have to make it as a different closure. Go to of I4. Is there any go to for I4? No, because after the dot there is no symbol. Then I5 also there is no symbol after the dot. I6, that is after the dot capital C. So go to I6 on capital C is I9. That is C gives small c capital C dot comma dollar. This dollar is copied. We cannot add any more items to this I9. Then I6 on small c, that is C gives C dot C comma dollar. Again the same I6 we will be getting, so we have given it as a self loop. Then C gives dot D comma dollar, that is C gives go to of I6 on D is C gives D dot comma dollar, that is I7. Then go to of I7 on something some symbol. Is there any symbol? No. So there is no need of declaring go to for I7. Similarly, in the case of I8 also after the dot there is no symbol, so no go to is there. In the case of I9 also after the dot there is no symbol, so there is no go to for I9. So this is the DFA corresponding to the CLR parsing table for the grammar S gives CC, C gives small c, capital C or D. So next is we have constructed the canonical LR1 collection. Next is we have to construct the parsing table for the CLR parser. For that, we have to make a table that is having both action part and go to part. States we have already identified from the previous slide, that is we have considered I9 closure from I0 till I9. So the states will range from 0 to 9. So how we can add the shift and reduce actions? Here it is saying that in the case of parsing action table, if A gives alpha dot A beta comma B is in I is in closure, then go to of I comma A is equal to IJ, then you indicate that as S shift J, similar to that of the SLR parser. But in the case of reduction, one thing you have to notice is that there we have written that reduce operation by finding the follow of the non-terminal on the left hand side, where we initially sought where the item ends. Corresponding to that closure, we identified the production's left hand side follow is to be computed. In corresponding to that closure and follow, we have to indicate the reduce action. But here the difference is that here we will not find the follow of the non-terminal, but we will indicate the reduce action corresponding to that closure under the look ahead symbol corresponding to the item. That we will be getting it easily while we look into the next slide. Then similarly, in the case of accept, as in the same case of SLR parsing table, where the S dash gives S dot closes, under that corresponding closure we have to write accept. So naturally, if there is any conflict, the grammar will not be SLR1. Then under the go to part, you refer the DFA and write the state. So this slide shows how we can construct the CLR parsing table for the grammar S gives capital C, C gives small c, capital C gives small d. We have constructed the closure, that is the set of LR1 item. So we have to go for the construction of SLR parsing table. The states are 0 to 9 because the closure ranges from I0 to I9. Then construct the action part and go to part. Under action part, all the terminals with the dollar symbol. Under go to part, the non-terminals capital S and capital C. Then here under 0, that is I0, wherever the go to goes, that is I0 on capital C, I0 on capital S, I0 on capital S, it goes to I1. So under the go to part, we can write 1. Under the go to part of 0 under capital C, we can write 2. So in the case of the small c terminal, I0 on small c, it goes to I3. So S3 we can write. Then I0 on small d, it goes to I4. So 0 under d, S4. Similarly, when we consider the I2, there is go to on capital C. So 2 under C, I5, that is 5. Then 2 under small c, it goes to I6, so S6. 2 under small 6, S6. 2 under small d, it will be S7. Then I3, that is 3 under small c, it will be 3, S3. Then 3 under small d, it will be S4. Then 6 is having the go to, 6 on capital C, it goes to 9. That is 6 on capital C. Then 6 on small c, it goes to I6 itself, that is S6. Then I6 on small d, it goes to I7. So 6 under small d, S7. Then, so all the go-tos corresponding to both terminals and non-terminals has been represented in action part and go-to part. The remaining is how we can write the reduce action. So these are the productions. Name it as the first production R1 is gives capital C. Second production R2, that is C gives small c capital C. Third production is C gives D. So R1 where it ends, if I have to find it out, that is where the item ends. S gives CC dot comes in which closure. So we have to identify that. Here it is coming under I5. So corresponding to 5 under this lookahead symbol dollar. Here now you have to find the photo. So 5 under dollar you can write R1. What is the case of C is small c capital C? That is C is C capital C dot R2. Where we can write the R2, that we have to find out where that closure comes, that item closes, ends. C gives CC comma dollar, that is 9. Corresponding to 9, we can write R2 under that dollar. Similarly, but while we look into that C gives CC dot, it also comes in I8. But the lookahead is different. But this part is called core part. The core part is same. So we have to enter corresponding to 8 also. 8 under this Z and D. We have to write R2. So 8 under C and D, we have to write R2. Here the lookahead is C and D, both C and D. Here the lookahead is dollar. That is 9 under dollar R2. So that is the case of R2. Third case is R3. C gives D dot. Where it ends. In the case I4 also, somewhere else, and I7 also. Even though the lookaheids are different, the core is same. So under 4 and 7, we have to write R3 under capital Z, small c, small d, and dollar. So 7 under dollar R3, then 4 under C, small c, 4 under small d, R3. Then we have to find where we can write the accept. That is the initial augmented grammar S dash gives S dot ends where. It is in I1. So 1 under dollar we have to write accept. So this is how we can construct a CLR. Another one is lookahead LR parsing table. It means it is actually the CLR parsing table. But since CLR parsing table has so many states, in order to avoid the reduce conflict or shift reduce conflict, we have constructed that CLR parsing table. So there is chance that there will be many number of states. It will be consuming so much memory space. So to avoid that, we are constructing LALR parsing table, that is by merging some states which are having the same core part. Here also it is having a lookahead, so LR1 items are to be constructed. So if we consider the previous example, here the only possible conflict that might come is reduce conflict only. Shift reduce conflict will not come in LALR parser. This is the table for LALR parsing algorithm for construction of LALR parsing table. This can be explained easily with the help of. So here we can consider the previous example itself for construction of LALR parsing table. Here in the case of CLR parsing, the LR1 item collection, observe the core part. Wherever the core part is same, with that closures can be combined together. In this case, it is said that We can combine I3 and I6 as well as I4 and I7, also I8 and I9. So consider the case of I3 and I6. I3, C is small c dot capital C. C is small c capital C. C is small d. Then I6 also the same production set of items we can see. Only difference is that it differ on the basis of lookahead symbol. Here the lookahead symbol is C bar D, here it is dollar. Even though the lookahead symbol is different, the core part is same, that item part. So we can combine these two. Similarly, I4 and I6, I4 and I7. Look into the I4. C is D dot C bar D. I7 C is D dot dollar. Only the lookahead differs. The core is same. Then I8 and I9. This is I8, this is I9. There also the lookahead differ. Only the core, the core is same. Only the lookahead differ. So we can combine those I8 and I9 too. So in the previously the CLR parsing table looks like this. In that now the 3 state is not there. Instead of 3 we will be representing it as 3 6. Instead of 4 4 7. Instead of 7 it is 4 7. And instead of 8 9 it is 8 and 9 it will be 8 9. So 6 is also will not be there. So 3 6. So we can remove one of the state and we can rename while we compare 3 and 6. Since the 3 and 6 can be combined, I can either cut off 3 or 6. It is normally we have to cut off the latest one. So earlier in this status 3, so maintain 3 and rename it as 3 6. So here it is 3 6. So wherever the S3 or S6 comes, we have to rename it as S36. So in the case of merging S3 3 and 6. So 3 is S3 and S4, 6 S6 and S7. So we have to combine like this, that is S36, S47, because 4 and 7 also can be merged. Then corresponding to this go-to part 8 and 9, so we have to combine it as 8 9 itself. Then similar the case of 4 and 7, 4 it is R3, 7 it is R3 here under dollar only. So while we combine it together, we merge it here, that is R3. 4 will be replaced as 4 7. This R3. And in the case of 8 9, also this R2 will be coming here. So 8 9 R2. So now the number of states has got reduced. Only 0, 1, 2, 3, 6, 4, 7, 5, 8, 9. The number of state has got reduced. 3 state we can easily got reduced. So LALR parsing table will be free from shift reduce conflict since this can be considered only if a CLR parsing table can be constructed. From the CLR parsing table only we can construct the LALR parsing table. So there will be, if CLR parsing table is not having any conflict, that will also reflect in LALR parsing table. Only chance is that there may be a reduce conflict. So we can say that LALR is intermediate in power, but it is good. It is because it can parse more grammars compared to SLR parsers, but only problem is that there may be chance of reduce conflict here also. That means if it is again as it having an LLR is also having a reduce conflict, means the grammar is not an LR grammar. You cannot be passed through any of the LR parser. So that is the end of module 3. We have discussed the construction of parse tree in both ways, top down and bottom up in module 3. Bottom up, the major technique is shift reduce. The two types is operator precedence and LR parser. The major categories of LR are SLR, CLR and LALR. So initially if you are given an option to construct a suitable bottom up parser, we have to construct and see SLR first. Then if the SLR is having any conflict, you go for CLR. Then in order to make it more affordable, you have to merge the state, so that you have to go for LLR parsing. And As an assignment you can do this LR parser, that is you have to construct a suitable LR parser for this below given grammar. First you augment the grammar, then you try SLR parser, then you try if there is any conflict for SLR parser, you go for CLR parser and submit the assignment at the earliest. The date will be announced in the WhatsApp group. Thank you.